Okay, so this is notes on chapter 3, section 2, Newton's laws of motion. And here he is, Isaac Newton. You can see him with his telescope, the prism he's working with, the planets moving around, a universal law of gravitation. We have this here showing his calculus in his invention of calculus with the apples and whatnot. Probably the greatest scientist ever, or close to it. His first law of motion is the law of inertia. We have these two people sitting in there in a looks like a train or a bus. If this stops, okay, um, the first law, the law of inertia, what's in motion stays in motion, what's at rest stays at rest. When this bus or this train begins to stop, the people inside will keep moving forward. Law of inertia. Now, this lady here who's buckled in will remain in her seat. She's tied to this seat, okay? But he's just standing here. So let's say this bus or this train's moving 35 miles per hour. He will continue to move forward at 35 miles per hour. He's going to hold on to this. He has to hold this to keep his balance, or he will go forward. This helps him to stop. All right. So the first law of inertia, what's in motion stays in motion. What's at rest stays at rest. The second law of motion, F equals ma. Force equals mass times acceleration. So when a force is applied to this ball, it will accelerate forward. This mass, instead of calling it a ball, let's just call it a mass. When a force is applied, this mass will move forward. It will accelerate forward. Okay. The more force, the higher the acceleration on this mass. So if a larger force is applied on this mass, I have a larger acceleration. Force equals mass times acceleration. Newton's third law, action reaction. Here's a hunter, and as he shoots the gun, the action of the bullet or of the powder pushing that bullet forward is going to push back on him. That causes a kick. The gun will kick. Okay. So for every action, there's an equal and opposite reaction for every force. Here's the action force. Here's the reaction force. The action is the projectile moving forward. The reaction is the force of the gun moving back against his shoulder. So let's see the first law in action. For first law of in action, what's in motion stays at motion unless a force changes it. What's at rest stays at rest until a force changes it. So here's some motion. And he's going to keep going until something stops him. Ouch. I got to watch it again. It's just ridiculous. I don't even look at his face. All right. Force is applied by that tree right there. It looks like there might be a rock there also. Don't know what would possess him to get in that car in the first place. Ouch. All right. What's at rest stays at rest. So the chalk's at rest and it stays that way. All right. It's going to stay that way. Eventually, gravity will pull it down. But you can see what's at rest stays at rest. What's in motion stays in motion. One more time. Boom. Very cool. Newton's first law. Here's another good one. What's at rest stays at rest. Awesome. What's in motion stays in motion. Okay. So the person falling is in motion. They're going to stay in motion. The net puts a force on them to stop them. The leaves, on the other hand, are at rest, and they will remain at rest until a force, in this case gravity, pulls them down. Boom. Very cool. Very cool. Here's Newton's second law of motion in action. Oh, little Happy Gilmore. He applies a force. That little mass, the golf ball accelerates. Boom. Force equals mass times acceleration. Here's a little F equals ma. Applies a massive force. Boom. Hockey player goes right through the glass. The force equals the mass times acceleration. This dude's force or his acceleration is high. He's got a big mass. So there's a big enough force to bust the glass. Be glad you're not sitting right there, right? Here's a little more F equals ma. Yeah. Take some of that. Force, mass, acceleration. You could also throw some inertia in here too. This guy's not moving very fast, but man, he gets drilled. Third law in action: for every action or for every force, there's an equal and opposite force. And he's in his Dragula here. You can see they're monsters. And here he goes, taking off, all right? For every force, the force applied to the tires, there's a force applied to the road, and the road pushes back and makes that car go forward. If you haven't seen this show before, The Munsters, it is a great show. Here's another action reaction. The engine applies a force to the tires apply a force to the road, and there we go. How'd you like to ride that school bus? That's my kind of school bus. Let's watch that again. Yeah, baby. Beautiful. One more time. Nice. I don't know why I put this on here. It's just awesome. For every action, there's an equal and opposite reaction. It's just so cool looking. I was thinking of it as a rocket taking off. Yeah. I could watch this for a long time. It's relaxing. But get out of the way. For every action, there's an equal and opposite reaction. Obviously, something wrong with this rocket. It doesn't go no more than a couple feet. Ah! You bet you get out of there. Watch this guy right here. He's like, whoop. Oh, man, get out of here. Bloop. Yeah, wouldn't want to be in that situation. That is crazy. Crazy. Bloop. One more time. Bloop. Awesome. For every force, there's an equal and opposite force. Okay. That's it. Hope you enjoyed the notes. And uh, good luck.